Good afternoon everyone. In this lecture series, we are going to discuss about the microwave passive devices. In passive devices, we are having some components, circulators and isolators. Already we have discussed about some of the passive components. Now we are going to discuss about the circulators and isolators. So why we need the circulator and isolator? The first main thing is we are going for the protection. So here in this microwave, the sources will be harmful and we have to protect that. So here we are going for the signal direction control, system stability improvement, how the improvement occurs in the stability of a system. We are going to enhance the efficiency, and the main purpose is the reliable improvement. What is a circulator? A circulator, it is nothing but it is a non-reciprocal device. So it is also known as multi-port device. What do you mean by multi-port device? Means a device with multiple ports. It may be 3 or 4. And the power flow, here we are seeing the power moves from one port to the next in a circular path. The rotation will be in the circular. The next one is the non-reciprocal. The non-reciprocal, the power flows directionally, not equally in both directions. It will flow in one direction and it will flow in the another direction, but it will be not same. What is an isolator? So it is the reverse process. Here it is categorized into non-reciprocal design. It is a two-port configuration and efficiency enhancement. This isolator is known as unidirectional. So the first one, it will prevent the reverse signal flow in the device. Suppose if the signal gets it will prevent that signal and it will allows the signal entry and exist through these two ports. And the main purpose is it has to improve the system performance by eliminating the reverse flow. These are all the uh, points in the isolator. The next one is the operating principle. So what is the component we are using in the isolator and what are all the components means is, since this is an non-reciprocal device, we have to know what are all the materials we are using. Suppose we are taking the ferrite materials. The next one will be the DC magnetic bias, the Faraday's rotation and gyromagnetic field. In ferrite materials, it will be a non-reciprocal power flow. It will enables the power flow in non-reciprocal. So what is the laws it has obeyed? Means it obeys the Faraday's rotation. The magnetic bias enhances the Faraday's rotation. If we are using this Faraday rotation, how it rotates the polarization and how it is influenced by the non-reciprocity. While coming to that of the relationship between the circulator and isolator, the signal integrity is very important. Suppose if we take the circulator, it will direct a signal flow in a circular path. But in case of the matched load impedance, what happens means it will first observe, then observe what is the reflected signals and it will prevent the interference. So these are all the ideal characteristics with respect to that of the practical characteristics, the performance of the isolator and circulator. So here we are having the ideal insertion loss, zero loss for the signal transmission, and there will be infinite solution and small losses due to the real world imperfections, and there will be a limited range. On the evaluation, we are having the losses, insertion, as well as the bandwidth. So here we want to provide the effective communication where it has been used means transmitter, receiver, radar and satellite system. So if we go for transmitter section, it will prevent the transmitter signal from interfering with the receiver. Receiver means it will safeguard the amplifiers from the signal interference. And in radar, it will ensures the signal processing. In satellite, it will maintains the signal integrity. So this is the mind map for the topic. Assessment questions we will discuss. Circulator and isolators, it is nothing but non-reciprocal microwave devices. A circulator is a 3-port or 4-port device. In an ideal 3-port circulator, power entering port 1 exists at port 2. Thank you.